Okay, so what we are talking about right now is how to name ionic compounds containing transition metals. So we've already talked about how to name ionic compounds containing other metals, and here's why this is special. So everything in this first column here has a +1 charge in an ionic compound. Everything in the second column here has a +2 charge in an ionic compound. But by the time we get to this third column here, that +3 is only true down to gallium. You can mark that on your periodic table, meaning that indium, thallium, lead, tin, antimony, all these guys over here do not follow the charges up here. The negative things are only going to describe the nonmetals, so they're going to be north of the staircase. So we've got this whole area from after the second column over here where we don't know what the charge is, and that includes this island down here. Okay, so they don't follow this +1, +2, +3 trend, so we need to figure out what the heck is this thing's charge. Okay, so first thing to notice is the fact that they're going to take on more than one charge. Iron could be +2, or it could be +3. Copper could be +1. Copper could be +2. So how are we going to know what charge? Well, I think it's worth writing down that transition metals can take on more than one charge. Why that is, we're really not going to get into right now, but one metal can become two different cations. So for example, we could have an iron that's lost 2 electrons and has a +2 charge, or we could have an iron that's lost 3 electrons and has a +3 charge. The way we share that in a problem is using Roman numerals. So I'll say something like iron 2. This does not mean I have 2 irons. It does mean this iron here has a +2 charge. This would be iron 3. So we don't need to know very many Roman numerals, but if you don't know them, it goes 1, 2, 3, 4, 5, and that's as many as we have to worry about. Okay, so we got iron 2, we got iron 3. It's, again, I can't emphasize enough that these Roman numerals are not telling you how many. They do tell you the charge of the metal. Okay, so just to give you an example, I could give you a compound containing both iron and oxygen. So these are both examples of rust. But I could give you iron 2 oxide, or I could give you iron 3 oxide, and we'll see that these are two very different compounds. So when we go to draw our little picture to help us keep track of which compound is which, I go and I draw a little iron, let's say it's +2, draw a little oxygen, and I go to my periodic table and I see the oxygen is in the column of -2, so I'll say -2. If I look at this and ask myself, is it more positive or negative with a 1-to-1 ratio, I can see that +2 is going to cancel out -2. So the formula for this is going to be FeO, okay? So over here we're going to see that it's going to be a little different. So in this instance, iron has a +3 charge, so I'll say Fe +3. Oxygen is oxygen, so it still has a -2 charge. That one's charge does not change. If the ratio is 1-to-1, I can see I'm a little more positive. So +3 and -2, right now they're canceling out to be +1. That's no good. We need the charge to be 0. So I will add another negative. Well, now it's -2, -2, and +3. So now I'm a little more negative. I need to add a positive. +3 is +6. Well, +6 is more positive than -4, so I need to add another oxygen. Well, now I'm neutral. I've got +6 here and -6 here. That adds up to be 0. So iron 3 oxide's formula would be Fe2, because I have 2 of them, O3, because I have 3 oxygens. Does that make sense? So even though these are both compounds made of iron and oxygen, when iron loses 3 electrons, it's going to react with oxygen like this. When it loses 2 electrons, it's going to react with oxygen like that. So again, they're both iron oxide, but in this instance, it's taking on a +2 charge. In this instance, it's taking on a -2 charge. Okay. Now, another expectation that I'm going to have for you is that you need to be able to tell me the charge of the metal based on the compound. So I'm going to flip the page, and we're going to look at that. So if I give you a formula, you need to be able to give me the name, including the charge. So here's 2 different compounds, both made out of copper and oxygen. So again, copper is another one of these that can take on more than one charge. We want to know what charge does it have in this compound, what charge does it have in that compound. Okay? These are both responsible for copper turning green. That's what that is. Anyways, I think it's again helpful to just draw a picture. So I'll draw, I can see here I have 2 coppers, so I'll draw 1 copper. I don't know its charge, but I know I have 2 of them, so I'll draw another one. And it's reacted with 1 oxygen. Again, you go look at your periodic table, oxygen has a -2 charge. Well, I've got 2 coppers and 1 oxygen that's -2. So you got to ask yourself, how positive is each one of these coppers going to be to cancel this out? Well, if each copper is +1, +1 + 1 is 2, which would cancel out this -2. Okay, so that means that copper's charge is +1. So both of those have a +1 charge. Well, so when I go to write that, I'm going to indicate that using Roman numerals. So I'll say copper 1 oxide. Again, check it out. I'm not saying that I have 2 coppers here. I'm saying the charge of the copper is 1. If I go up here, I can do the same thing. I'll draw 1 copper, because that's what the formula is indicating. I don't know the charge. It's reacting with 1 oxygen, which is -2. How positive does it need to be to cancel out a -2? It needs to be +2. So this one's going to be written as copper 2 oxide. Okay? Please shoot me an email if you have any other questions about this, but this is how you name and write the formula for ionic compounds containing transition metals.